going off. Okay. All right, here we go. So I'm just going to call this section 7-1. 7-1 we don't do, and our book doesn't really have you do this, so we're just going to call it 7-1. So chapter 7 is logarithms. Let me start that off. Bad marker. Come back here. So chapter 7 is an introduction to logarithms. Introduction to logarithms. And a lot of times, just to say, I'll say logs. So if you just see logs, you know that it's a logarithm. Okay. Section 7-1, we are going to call it working with common bases.
Can we start with it?
Yeah.
Can we throw away our notes from last
I would throw them away because all that stuff could show up, in future applications. Like I know we have to go back and factor again and do all that stuff. So I would say, but I just pick up wherever you left off. That's what I would do. Okay. All right. Here's what I mean by common bases. Let's kind of think about this. If I gave you 2 to the x equals 2 squared, what can you conclude? What's x going to be equal to? X has got to be 2, right? Okay. If I put a 2 in for x, then 2 squared is equal to 2 squared. So notice when you have a common base, what can you assume about the exponents then? Exponents are equal to each other, right? If my bases are the same, then I can conclude that x is equal to 2. My exponents are equal. So if you have a common base, you can assume exponents are equal. Okay? So that's really important in learning how to solve exponents. So when my base is the same, then I could say, hey, x is equal to 2. My exponents are equal to each other. Now, how does that apply to solving a problem? I could go to the next step and do something like this. Like that. If my base is the same, can't I assume my exponents are equal to each other? So 2 equals 2, so therefore 2x equals 6, right? My exponents are equal, and then I can just divide by 2. X is equal to 3, okay? So working with common bases, if I plug in 3 here, 2 times 3 is 6, well naturally 2 to the 6th is equal to 2 to the 6th, okay? So this is how common bases work, okay? Now, why is this tie into logarithms? And you don't need to write this down, because if I give you a problem like this, is there any way to convert 2 and 3 to the same base? Can you make them the same? No. So we just can't say x equals 2 in this case. So then that's when logarithms come into play. So today, all of your problems, you will be able to work with a common base, okay? And I just got a couple examples here. And as we pertain to something new, we'll go over the steps as it happens. So your equations could get a little bit, kind of complicated. Like here, the very first thing I look for is, do I have common bases? Because if I have common bases, I'm ready to go, okay? Well, since I have 3 equals 3, then I can just set these equal to each other. And now I just solved that equation, okay? I think we're going to be okay solving equations and so forth, so I'm not going to spend a lot of time talking about those. But to solve this, I would just add n to both sides. Subtract 1. Don't be alarmed if you get fractions. I know a lot of people are like, oh, I got a fraction, it must be wrong. No, it could be right. You just get fractions, okay? So, any questions when you have common bases? Now, here's a few special circumstances. These will pop up from time to time, and it kind of messes people up. How about this one? Can you convert a 3 and a 1 to common bases?
Yes.
You can.
There's a,
No. But you can, anybody got an idea? It's a kind of a trick question. What?
Power of 0.
Power of 0. What's anything to the 0 power? 1. You guys remember, and we haven't done it in a while, anything to the 0 power is 1. 4 to the 0 is 1. 10 to the 0 is 1. So I can convert this to a common base. I can say 3 to the negative v equals 3 to the 0. 3 to 0 is 1. It's the same thing, okay? Now that I have common bases, I can say, hey, negative v is equal to 0. I don't know, divide by negative 1, v is equal to 0. Does that make sense? If I plug in a 0 for v, what's 3 to the negative 0, or what's 3 to the 0? Positive 1, okay? So whenever you have equal ones here, you need to rewrite it as a common base to the 0 power. They both mean the same thing. Good? Special problem. One pops up every once in a while. All right, here we go. Now this is where it gets a little different. How about something like this? This is the whole thing about common bases. What if I gave you 16 to the 2x equals 4 to the third? Notice you don't have common bases. So it doesn't mean you can't do it. It means you have to figure out how to convert them to common bases. Andrew?
Can't you square root 16?
Don't square root, no. No. We want to convert this. Let's think about this. Is there a way that I could take 16 and convert it to base 4? In other words, 4 to the what is 16? 4 squared, right? Could I just say, hey, wait a minute, 16 is 4 squared. Notice you still have a 2x out there. Do you have common bases now? Yes. So here's how you do these problems. You always convert the larger number to a smaller number. Like some people will say, wait a minute, I want to convert this to 16. Don't do it that way, because then you got to use fractions. Always convert the larger to the smaller, okay? Well, I know that 4 squared is 16, okay? So this and this are the same thing. Now, what do you think you're going to do with these exponents? You have a power to a power, which means you multiply. This is 4 to the 4x equals 4 to the third. You have common bases now. Okay, so see what I did there? I always look at the largest number, and I know that I can convert 16 to a base 4, 4 squared. And now I just apply my laws of exponents. I have a power to a power, so I'm multiplying together. Now I have common bases. And now that I have a common base, I can just set my exponents equal to each other and solve for x. Makes sense? It's kind of a weird, it's a big jump. It's like, wait a minute. This all seemed pretty easy until we have to convert these now, okay? And here's the crazy thing about this problem. Is there another way I could have done this? Does anybody have another idea how I could convert this? There's actually another way I could have done this. I could convert it to what? No, you can't. Again, never convert the smaller to the larger. Never do that. It's really hard, and sometimes you can't. How about this? Base 2. 2 to the what is 4? 2 squared. 2 to the what is 16? Nope, that's 8. 4. I could have converted these to base 2s. They both convert to base 2. Watch what happens. I get 2 times 4, or 4 times 2x, which is 8x. 2 times 3 is 6. Notice that if I have my common bases, I get 8x equals 6, divide by 8, x equals 3/4. I get the exact same answer. And I went to a different base. I converted to base 2, not base 4. See how it works? These problems get a little bit lengthy, like in solving. It is very important that you show your work today. And I left room on your worksheet. Like even on here, when I already have a common basis, I just set these equal to each other, but it still took me a little bit of work to solve it. So I need to see this, and these first steps are really important of how you get these to be common bases. Okay? Good so far? We're gonna just throw a bunch at you here. Here we go. Let's make it even more complicated. How about this? I gotta switch the order around. Let me do this. So you may need a calculator today, but hint, if you just always look at the other problem will kind of give you a hint of what it needs to be, okay? Talk about fractions. No fractions. Okay? If I see a fraction, here's the very first thing I do. I'm gonna get rid of it using a negative exponent. We don't want to work with 1/5. So I could rewrite this as 5 to the negative 1. Okay, to get rid of a fraction, or to get rid of a fraction with exponents, you just use a negative exponent. If I had 1/2, I could rewrite that as 2 to the negative 1. If I had 1/10, I could say that's 10 to the negative 1. We don't work with fractions, so we always convert it. Okay? We understand that? Okay. Now let me ask you this. Is there anything lower than a 5? Is there any number that you could take like 2 to the second, 3 to the second? Is there any way to convert 5 to any lower base? No. So that's my hint. I got to figure out how to make this a 5. I know I got to make it a 5. 5. It's got to be a base 5. Well, 5 squared is 25. 5 to the third is 125. What do you think 5 to the fourth is? 625. Now, I want you to notice how I always write my problems. Do you notice that I always put it in parentheses? 5 to the fourth is 625. And I rewrite whatever's on the outside. What am I going to do with these two numbers now? What are we going to do? You're going to multiply. You have a power to a power. So that becomes 5 to the 4x equals 5 to the negative 1. I can solve this now. I have a common base. My bases are the same, so therefore 4x equals negative 1. Divide by 4. Okay? So as soon as you see a fraction, use a negative exponent to get rid of it. Always get rid of it. Okay? All right. Make it harder yet. How about this one? So this is where showing your work is really important. Okay. We only got a couple left. We're almost done. All right. Right off the bat, what do you see that you don't want? You have a fraction. So how am I going to get rid of that 81?
Negative exponent.
Yep. So I'm just going to rewrite this as 81 to the negative 1. That would be my first step. I do not want fractions, ever. So I just use a negative 1 to get rid of it. Now we got to figure out a common base. What do you think our common base is going to be? It's going to be 9. Okay. This is base 9, so that's good. Let's leave it. Well, 81, or 9 to the what power is 81? 9 squared. So notice that you already have a negative 1 there. And now you're saying 9 squared. What's 9 times, or what's 2 times negative 1? Negative 2. I'm going to just stop right there for a minute. Do we agree that 1 over 81 is 9 to the negative 2? Okay, it's 1 over 9 squared, which is 1 over 81. So this is good to go, but look at this. I still have this 2x plus 1 out here. Here's where you really got to be careful. What are you going to do with these exponents? You're going to multiply. And when I say multiply, it's just not negative 2 times 2 and call it a day. It's negative 2 times everything. So when I write this problem out, notice how I write it. Parentheses are so important when you're working with these exponents. It's negative 2 times everything. So it's negative 2 times 2x plus 1. I got to multiply everything, okay? And then equals 1. So now, with parentheses, it lets me see that it's negative 4x minus 2 equals negative 1. Right here is where most people will miss this problem. They'll forget to distribute the negative 2. Now we just solve it like we normally would do. We're going to hit this fast. So negative 4x equals 1 divided by negative 4. I mean, do you notice that almost every single problem we get fractions? Almost always. So don't be alarmed, okay? Good? Kind of weird stuff, isn't it? All right, I got one last one. This would be what I would say the granddaddy of them all. This is like the hardest problem you would see, okay? Let's see if we can do it. They're not all like this. You know, I definitely started off with the easier ones, but we got to kind of spend a little bit more time on these harder ones. Here we go. 9 to the negative a times 3 squared equals 81. So, first off, since your bases are different, you can't add these together. These are different bases. Okay, you just can't say 9 to the negative a plus 2, for instance. So, as Aiden said, but look at all your numbers. I can convert our numbers to what? Base 3. 3, I can convert that to base 3, and I can convert to that to base 3. So let's do that. Let's convert everything to base 3. This would be 3 squared. I still have a negative a out there. This is already in base 3, so I don't have to worry about that. And this would be 3 to the 4th. Very good. Okay? Just like your skill drill. That's why we're working on exponents. What are you going to do with these exponents? You're going to multiply them. So this is going to be 2 times negative a. Okay? Look at that. You have a common base. And when your base is the same, what do you do with your exponents? You add them. Can you add these together? No. So you're just going to go negative 2a plus 2 equals 3 to the 4th. You can't physically add them together, but I can write it like that. Negative 2a plus 2. That plus that. Now that your bases are the same, you could set your exponents equal to each other now. And now we just solve it like we normally would do. I'm going to do this quick. Oh. That's a lot of work. I mean, look at it. That's quite a bit of work just to simplify this problem. So let's go through our progression. Number 1, we first got to convert everything to common bases. And we noticed that 3, 9, and 8. And, you know, you're going to notice on your worksheet 25s show up a lot. 125s, 3s, 9s, 27s, 81s, 4, 16. Those are all common bases, like base of 2, base of 3, base of 4, etc. Okay? So I converted to common bases. Again, guys, whenever you convert, always just do it in parentheses. 9 is 3 squared. Because then it lets you see that you got to multiply those two together. Okay? Now that I have more than one common base, I have to add my exponents together. Now that I have a base 3 equals a base 3, then I can just set those equal to each other and solve it. Okay? So a couple things. How do you get rid of fractions? How do you get rid of a fraction? A negative 1, a negative exponent, and then convert. Okay? Number 2, when you have parentheses and you have a power to a power, you always multiply them together. Okay? This one and fractions are used the most. Okay? Any questions? Kind of different. Probably haven't seen these before. So like when we get to this step, and you can't do nothing like with common bases, now you have to go to the next step, which is use logarithms. I would have to take the log of both sides and solve it by logarithms. That's not going to happen today. Everything will convert to a common base for you today. Okay? Some of these get kind of weird at the end. All right? The first 20 that you do are pretty straightforward, pretty darn easy. But then I put some of these on there that are going to make you think a little bit.
I never.
Yeah, you do. You just don't. You just don't realize that you're thinking. How do you get rid of a 1? What do you put in its place? A 0. Base, whatever the common base is, to the 0 power.
You're frozen us.
I know. We got to be locked in on this stuff.
Locked in.
Locked in.
Locked in.
You know it's coming.
Locked in.
Like, you can't go.
I'm
Don't worry. Right.
So, let me show you one that I want to. This is what I need to see from you. Look at number 1. Is number 1 ready to go?
Yep.
Yes, you already have common bases. So, let me just write it out. So here's what I'd like to see. If you have common bases, you're ready to go. Just set your exponents equal to each other. Just, if you got common bases, there's nothing to do other than solve it. Okay, now how would I solve that? What would I get rid of?
K plus K.
I would add k to both sides, exactly. And I wanted to work this one out. I had it as an example and I didn't do it with you. What's negative k plus k? What number is that?
0.
Yes, a lot of people like to put no solution here. This isn't no solution. Negative k plus k is 0. And now you just divide both sides by 3. 0 divided by anything is 0. Okay?
That was a tricky one.
So be careful of that. I mean, empty set can happen, and all reals can happen. It's just that this case, it's not. The only time empty set happens is if your variables are identical, and they cancel out. Which one out of 1 through 16 looks pretty messed up?
12.
12?
Yeah.
I thought you guys would say 10, but
They both
12.
look bad.
But I thought I would help you with 12 then. Okay.
I'm thinking that.
We'll do 12 just as one more together. Yeah, 12's kind of messed up. Well, right off the bat, what sticks out that you can't have?
Fraction.
You can't have a fraction. So the very first thing I would do is I would rewrite this as 243 to the
Negative.
-1. That would be the very first thing I would do. Okay, is convert that to -1. No fractions. Now we got to figure out a common base. So when you think of 81, what's our normal common base?
9.
9, but I don't know if 9 to the third is that. 3. If you could always convert it down to the lowest, 9 might work. What is 9 to the third? Anybody? Anybody got that? Do that on your calculator. 9 to the third.
720.
So it's not 9. So, but I know 3 will work. So I'm going to convert this to 3 to the fourth. 3 to the third is 27. 3 to the fourth is 81. So again, I'm going to put that in parentheses. And now I'm going to convert 243 to base 3. 3 to the what? And just mess with your calculator. Go 3 to the 5th. Go 3 to the 6th. What is it?
It's been
5th. And notice you already have a -1. So it's going to be to the -5.
Which is very valid.
Okay? So now we have powers to powers. We don't want that. 4 to the 3x is 4 times 3x, which is 12x. -5 times 3x,
Negative 59.
and now we can solve this. I have common bases. I have 12x equals 15x, almost identical to this problem. Your base is the same, so set your exponents equal to each other. This is not empty set, because these don't cancel out. So which one do you want to move? Let's move the 15. Let's add 15 to both sides. You got 27x equals 0. And what's 0 divided by anything? All that work to be a 0.
Yeah, that's kind of dumb.
Okay? But hey, 0's a number. I know like people like that's 0, but 1's no different than getting 1 or -1. It's just a number. So, but you see my process? I first got rid of the fraction, negative exponent. I then figured out common bases. Always think of 3's and 2's and 4's and 5's. Okay, you're not going to have a common base of 15 because those are gigantic numbers. Then I converted to base. 3 to the 4th is 81. I multiply, and now I solve it. Okay? So, the first few, notice that I set up with common bases. Notice they're pretty easy to convert, but when you get to that backside, which we have almost half hour, try to get to that backside, because I know you're going to have some questions on those. Those are a little bit more complex, okay? Given mood today, get the first page done, extra credit. You get the second page done, more extra credit.
Good something.
So just before you leave, have me check it off for you guys. First page you should get through pretty quick. So that's easy extra credit.
How does that work?
Oh, did you stop it?